Good to see everyone. Big room, so hopefully you guys can hear me at the back with the mic. Move forward if you have any issues. But I'm going to talk to you about prompt engineering, and it's a field that has only really existed for like 4 years, maybe. Started to get interesting, but I've been in the field for all 4 of those years because I come from a marketing background. I basically got into AI when GPT-3 came out and was like kicking around with nothing to do and just messed around with it. And now I'm working in it full time. So hopefully I'll be able to give you guys a bit of a flavor of how it actually gets into production. Because I think that talking to a bunch of people, there's a lot of hype in AI, and there's a lot of cool demos that you can do, but it's a really big difference between a demo or a prototype and then something that's actually working with real users. So that's what I'm going to try and focus on, trying to make it as practical as possible, sharing some of the insights that I've had working on some of these projects. Like we were saying before, if you guys download the app, if you haven't already, then you can submit questions through there, and then also give me a rating at the end, whether you're happy or not, right? So I come from a marketing background. I left my marketing agency in 2020, which is why I had a bit of time to mess around. Really good timing. It was during COVID lockdowns in the UK. I know that there's kind of various situations in the US, but for us, had nothing to do but mess around with AI, which was quite nice. And then, since then, I've created online courses about AI and marketing, seen by 400,000 people. I think it's 450,000 now. So we have the top Udemy course on prompt engineering. 120,000 people have taken that one specifically. And then I just published a book with O'Reilly, which is pretty cool because I learned how to code by reading O'Reilly books, so that was quite a fun experience. I know there's a bunch of O'Reilly authors here as well. I actually have a workshop tomorrow where, if you attend that, I think there's some spaces left, you get a free copy of the book. So check that out if you're interested. So what are we going to cover? I've got the Jupyter notebook here, so you guys can take a look at this afterwards if you code and you want to, kind of mess around with some of this stuff. So don't feel like you have to take a bunch of notes. I'm going to share these slides afterwards with Bente, so you guys should get this. Also I'll put some way to contact me in there if you have any questions or you want me to elaborate on anything. We're going to go through the 5 principles of prompting. This is kind of like a checklist I had to develop when I was writing the book, because when you're writing about AI and it's going into print and then everything changes every single week, that's a real problem. So what we had to do is really think about what are the things that worked back when GPT-3 was around and still worked after GPT-4 came out, and then plot ahead and kind of say what are the things that will continue to work with GPT-5, GPT-6, et cetera, or whatever model we're using in the future. And the really interesting thing is that a lot of the insights we found through that process really applied from back when I was running a marketing agency, managing 50 people. The same sort of things that make you a good manager also make you a good prompt engineer, which we'll talk about a little bit more detail. So I'm going to run through those, and you can kind of treat that as a actionable checklist. You can go away today and make your prompt ready for production once you run through these 5 steps. I'm also going to talk about what happens after you get to production. So these are 3 kind of recurring day-in-the-life type activities: A/B testing prompts, using DSPy, like an automated optimizer. I'm going to kind of show you an example there, and then also doing fine-tuning of your, to create a new model that you can use in production. And then we're going to finish on the business case for prompting, hopefully kind of convince you guys that it's not all about building these foundation models. Actually, a lot of the heavy lifting and a lot of the stuff that makes AI products work in production is really at the prompting level. Cool. So what is prompt engineering? This is a naive prompt, is what I always start with. If you're trying to do a task, like in this case, a summarization task, you want to basically start with the simplest possible prompt. Like what would you just type into ChatGPT? And if that works, then great, you're finished. You don't need prompt engineering. And actually 80-90% of the time, you don't need prompt engineering. it might be overkill, especially because these models are so good now. Back when we used GPT-3, I had to use all sorts of tricks and hacks to get it working. And I would say that as the models get better, more often it just works out of the box. When you need prompt engineering is when you're going to be running this a lot of times. So you're going to run it thousands of times, millions of times in some cases in production, and you need it to be able to work reliably every time. So just a kind of a little hack here, by the way. It's quite fun. If you put r.gina.ai in front of a URL, it gives you a nice markdown text from that URL. So it scrapes the URL and gives you the text. So it's really good for AI inputs, like if you're going to be kind of reading different landing pages. So that's what we've done here. So we're just getting, this is an article that we wanted to summarize, and we're just getting the markdown text that we can then put into the prompt. And when it comes to prompt engineering, typically I'm doing that in a Jupyter notebook. I know that a lot of people will use ChatGPT and call that prompt engineering. I would say that that's just prompting, right? Like if you're not running a script or you're not kind of doing it at scale for something that you want to put into production, whether it's an internal tool or an external tool, it's using principles of prompt engineering potentially. And a lot of the stuff is actually useful for non-technical people, but I try and reserve that term. Like if it's got the word engineering in it, you kind of need to be doing it at scale, or at least making the thing you're doing more scalable. So I start with Jupyter Notebooks. I usually write a simple script just to call the base native API. I don't use a lot of frameworks like LangChain, a few others. They are good and they do have their place, but I would say you want to really keep the thing simple at first, and then once you know what works, then you can go for the abstractions that you might want to be using in production. Because these models change so often, and because your tool will probably change quite a bit on the path to production, you want to keep this tech stack as simple as possible when you're doing R&D. So this is just a simple function that I wrote. Actually, I don't even write these functions anymore. I used to try to keep one and keep using it in every project, and now I just use Cursor as an AI kind of version, fork of VS Code. If you guys have used that, and I just say, at OpenAI documentation, because you can pull in the documentation with that tool, and then I'll say, just write me a function to call OpenAI. So I don't even have to think about this anymore. It's not something I worry about. And for throwaway code like this, when you're doing R&D, it's not something you really need to think about. That's one of the, like when you're not in production, don't adopt all of the overheads that come with production, right? When you're doing R&D, you want to keep it really scrappy. So here we're just putting in the naive prompt, and then that's going to be our baseline. And this is what the naive response looks like. So the summaries are actually pretty decent. One problem that you have with summarization tasks is that you tend to lose all of the intent of the original author. So it sounds very boring. It sounds like AI if you read that, right? And this article was quite politically motivated, right? And we're not going to get into politics. I know the election is like a few weeks away. So I wouldn't want to get into that topic. But in particular, one thing that is bad is if you lose some of that semantic information. If the original article was really in favor of one candidate or really against another candidate, you actually want to maintain that in the summary because this is actually a bad thing. I think if you debias some text, then you're losing some of the initial intent of what the author was trying to get across. So whichever side you're on. So this is an example of what we're going to work towards. This is a prompt engineered example, like an optimized response. And this took several iterations, but it's already much better. So you can see that a lot of the bias of the original article is now maintained. So this is kind of keeping a lot of the intent and the semantics and the words that were used in the original article, but it's also adding a couple of other layers here. So we have some fact checking, right? Like we have some kind of lookups being done with another AI service, which I'm going to kind of talk to you about. So this is a much better summary for the use case that I was working on this for. Obviously, I'm not sharing the exact use case for this client. NDAs, et cetera. But this is kind of like a toy version of the problem that we're solving. So how do we get from the first example that we saw, the naive response, which sounded like AI and wasn't that great, to this response where we have multiple layers of things happening? Well, the answer is prompt engineering. And typically when someone looks at AI on social media and they say, wow, that prototype looks great, but I'm not getting those results myself. I tried it and it doesn't work. It's usually because they're not using prompt engineering. That's usually the major difference between these wow kind of demos that you see, and then what in papers, on Twitter, etc., and like the first time you try the tool and don't get the same results. My definition here is that basically prompt engineering is this process. It's where you're trying to discover a prompt that reliably yields results, and reliability is the key here, because when you're having a prompt in production, because AI always gives you a different result every time you run it, those results can sometimes be really bad, and things that your users would complain about. You might have legislative responsibilities, ethical concerns. So it's really, really important that you've tested this prompt thoroughly before you deploy it with real users. So what are the 5 principles of prompting? This is my checklist I run through every time. Thankfully, most of the time you don't have to go through all 5. Because these models are so good and getting better all the time, like every 3 to 6 months, we see a major leap forward. You hopefully only need to do 1 or 2 of these before you get good results. But the first one I always try is to give some direction, give some instructions in the prompt. And this is the easiest to do because typically you have some idea of what is wrong when you run that naive prompt. So straight away, I can just say, hey, the thing that's wrong here is that it's not preserving the nuance of the author's intended tone. So that's the instruction I added in. It doesn't have to be super complicated. Obviously, you get different results when you word this in different ways, and you can spend a lot of time really just writing and rewriting instructions in order to get to something that actually kind of follows what you're hoping to get. But in general, this is the case of just iterating and saying, okay, well, what's wrong with it? And then let's add that. Let's address that in the initial instructions. Quite often, you're doing role prompting in this step. So you can say, as a journalist, I didn't do this in this section, but you could say, as a famous journalist, maybe you can specifically name the journalist, someone that the AI would know about. I want you to summarize this article. So if you said, as Rachel Maddow, potentially it would preserve some of her initial kind of tone. Or if you said, as Brett Baer, something you could get completely different tone. So that's kind of a shortcut. But what I like to do is I like to describe specifically what I like about, say, Rachel Maddow or Brett Baer. What is it about their style that the AI should emulate? Because if you're just copying someone's style specifically, they might have some aspects that you don't like, that you don't want. So if you break that style down, then I tend to find you have a little bit more flexibility. Cool. So with just that change, this is the response that we're getting, and it is much better. I won't, make you read a block of text, but you can trust me, or you can read it afterwards, when you get the PDF. But it actually does keep a little bit more of the initial intent of the author. So the next thing I move on to, and this is the most important one, I think, for production, is the format. You want to output a specific structure, data structure. You want to output a specific set of things, or maybe variables that you're going to be using, dumping into your database, or saving in a spreadsheet, or displaying on a web page. That tends to be the next thing that people work on. And thankfully, this has gotten a lot easier. Models like the foundation models, the latest state-of-the-art models, are really good at following these instructions now. They have things like JSON mode where you can guarantee that it's always going to give you back JSON. So that's a little bit less difficult, but where I use the specify format principle is in really kind of guiding the model to the way I want it to think about the specific problem. So in this case, I'm using somewhat of a chain of thought method. If you guys have heard that technique, it's what powers the latest model with ChatGPT, the O1 preview model, the reasoning model, is that that's kind of been trained into it. But before that, it was a prompt engineering technique. You tell it to think step by step through the problem first, kind of make a plan, do some thinking first before answering the question. And this is a very generalizable technique that you can use in pretty much any prompt. And the reason it works is the same reason it works with me and you. Right? Like, I didn't just wing this presentation. I came up with a plan of what I'm going to tell you first. And that made sure that I was very comprehensive with my results. It helped me make sure that it was going to be an interesting presentation, hopefully, you'll agree. Because that works with us, we spend some thinking time ahead of time to plan out what we're going to do and how we're going to approach a problem. Then that also works for LLMs, because they are, in effect, trying to simulate the way that we think, although imperfectly. So the way that I've specifically implemented this here is I just asked it to list 3 to 5 key takeaways. I found that that maintained a bit more of the semantic information, the main points. Otherwise, the summary kind of condenses and you lose some of the important things that, that the article was saying. So when it lists the 3 to 5 key takeaways first, then the summary ended up being much better, much more comprehensive, which was really helpful. And you can see in the response here, we are getting JSON, we're getting the key points first, and then we get the summary. And this is also really helpful for debugging, because LLMs are really hard to debug in general. Like, you don't want to read a block of text every time. Who knows whether that summary is good or this summary is good? You get really bored of looking at these things after a while, and you've been doing it for days. So one of the things I found is just looking at the key points, I can see if it captured the main intent of the article. Even if I don't know that much about that article, it allowed me to kind of test a wider, diverse set of test cases, which was really helpful. Because I could quickly scan the key points and go, it's done something really stupid here, and therefore, or it's missed this completely, and therefore I know that the rest of the response is invalid. So that's really helpful. Third principle here, and this is the most impactful one. If you remember literally nothing else from this presentation, the main thing you should know is you should give examples of the task that you're trying to do to the LLM in the prompt. So this is, there's a ton of literature on this, even pre-generative AI. AI researchers or machine learning engineers would always look at the results of their models based on zero shot or few shot is the terminology they use, right? So a zero shot is could it answer a question without you giving it any examples of how to answer the question? And few shot is where you give it maybe a handful of examples. And with every AI model, including the best AI models, their zero-shot score is always much worse than their few-shot score. Like, if you give it a handful of examples, it can interpolate between them, kind of understand what it is you like about those responses, and therefore it can guide it into doing a better job. And it doesn't have to be the full input and output is one thing I found. You can actually learn a lot just by giving the output. And this is something that most of the gains, I think, when you see a prompt that's really had a double-digit increase in performance, most of the gains come from just adding a lot of few-shot examples and working with a domain expert to manually create them. I think that is usually like the vast majority of the work, because if you can give it a few examples, it's often a lot easier to communicate all of the nuance of what you want. Because can you imagine describing exactly what you like about every single summary and then putting all of that in the instructions? It's very manual work. Quite often you could just select a few examples of summaries that you like and then stick those into the prompt. So that is quite helpful. In this case, I specifically just wrote these manually myself. I generated a couple of examples from other articles, and then I rewrote them. I just kind of edited them to be closer to what I liked. So that's typically what a prompt engineer is doing early on. They might create a few examples themselves based on the brief from the client, but typically you want to get a domain expert in there, someone who's an expert in summarization, or maybe even just like the product manager or the CEO, someone who understands the business case for what this product needs to do, or maybe a few of the end users can specifically tell you what's good, what's bad about, here are a handful of good examples, here are a handful of bad examples. Cool. The other thing that this does is really helps it nail the formatting as well. So if you're struggling with that second step, if you just provide even just 1 or 2 examples of that formatting being used, then it does a much better job at adhering to that. So here it's doing a good job here with the key points, just in general, I think the semantic tone is starting to get much better. I specifically made those other examples more biased, right? And that was how I kind of communicated that I wanted that political bias in the summarization as well. And I did, both sides as well. So, so it has like a diverse set of understanding. It knows that it's not just going to create like left-leaning bias or right-leaning bias. It's going to be bias that matches the original tone of the article itself. Then usually it's working by now. Like usually it's working pretty well, and you would see, at least from a vibe check standpoint, you've looked at it and you're like, hey, this is actually kind of good. I'm pretty happy with this. And now it's time to formalize that evaluation, because it can't just be you manually checking everything every time. It's going to be too slow. Good luck getting your CEO to manually check hundreds of examples when you're doing an A/B test, right? Or hiring a domain expert is very expensive. They're usually very busy. So it might take weeks for them to come back to you with some of the labeled responses. So typically you want to formalize your evaluation metrics in some way that can run every time you run an experiment and conclude in less than a couple of minutes. Because otherwise it's just going to be very, very slow to run experiments, and then you're kind of losing one of the major benefits that you have with LLMs. When a human is doing this task, it might take days, weeks, months. You can't A/B test with humans very easily. They don't like that, right? It's what I found. So if you're trying to give one set of instructions to one team member and another set of instructions to another team member, we have a sense of fairness, and it really annoys us. I wouldn't suggest that. But with LLMs, you can do that, and you can run these experiments. You can actually kind of see, okay, well, when I describe it this way, it actually does much better. And actually, I'm seeing with a lot of my clients, as they get better and better at evaluating the performance of these LLM pipelines, and as they get better at describing the task it is to do that we need to do, and adding examples, building that kind of database of good examples, it's actually a little bit of a gateway drug into actually doing a better job managing their employees, which I think is a hopeful message, because you can take some of the lessons that work with LLMs and then apply them back into your human workers as well, for those parts of the pipeline that you can't readily automate with AI yet, right? Typically there are a few different types of evaluation functions. The best ones to run are ones that are deterministic. So if you can code it, right? Like if you can, it can be a function that you run that classifies the result. That's perfect, because then you can A/B test all day long. Even if it's not even if it's not like 100% accurate, it doesn't 100% agree with the human domain expert, it's still good directionally to rapidly A/B test, and then you can go validate those results with the domain expert. So in this case, I've chosen Rouge score, which is used for summarization. And again, when you're in Cursor or you're using Claude or ChatGPT, you can just ask it like, how would I evaluate this? And it can actually usually come up with some precedent for how people tend to evaluate these things. Obviously, you want to fact check that, but you could get it to write the code for you to calculate the Rouge score if you've never heard of that, for example. So, the other thing I do, kind of an additional layer here, is I'm using an LLM judge, which is really helpful when you don't have that access directly to a domain expert all the time, and you want to kind of speed things up. So in this case, I'm calculating the Rouge score, and then I'm passing that to an LLM judge, which is, again, just another prompt that you can optimize as well. And I'm just asking it to interpret these scores and choose a winner. Again, I'm being very lazy here. Right? Like I'm calculating the Rouge score, and then I'm passing those Rouge scores across to an LLM judge to choose between them, right? So I didn't even have to look at the scores and interpret them myself. And you can really extend that concept out quite a bit. There's a lot you can do with LLM judges. Again, I would say that because it is another prompt. You still have to optimize that prompt and check whether that agrees with the human judges. This is kind of starting this whole cycle again. And you can see here, this is kind of example response that you get. Again, you want to use chain of thought here. So in this case, I've asked it to kind of, it's explaining the reasoning a little bit first before choosing a winner. You want it to choose the winner at the very end because that's going to give it much less biased answers and much more repeatable, reliable answers. So every time you run this, it's going to say winner 2 with the exact same inputs. You don't want it to be fluctuating and sometimes choosing winner 1 with those same inputs, right? But now we've kind of gotten on to what I think is the 5th principle here, which is dividing labor. It's very, very rare, I don't think I've ever seen it, that an AI system in production is only using one prompt, right? That almost never happens. You can get a good demo, but you can't get great, reliable results only using one prompt. Usually it's a chain of prompts strung together, or in some cases an agent, although a lot of them are pretty unreliable. I would say typically you want to kind of chain multiple responses together where the inputs of the next prompt in the chain are the outputs of the previous prompt in the chain. A good example of this is, in this case, we wanted to add citations to the summaries. We've already solved the initial problem of maintaining the political bias of the original article, which is good. That's now we've kind of kept that semantic information. But the other additional thing we wanted to know here is, like, did it get the facts correct, right? Because that's different from political bias, although they are kind of intermingled. So I'm using another AI system here called Tavily. There's a bunch of these, but essentially that would go and do a web search. So if you're used to Perplexity, if you guys have used that app, similar sort of concept to that. They also have an API you could have used here. But essentially, it will do a web search, and then take the results of that web search, scrape those URLs, and then put the text into the prompt, and then you can kind of choose a question to ask based on that context. So it's a really great kind of general way to fact check stuff and get up-to-date information, is to kind of give it to one of these web search agents that can kind of then summarize the information and give you back a response specifically on that key point that was made. You can see this is the type of response we're getting here, and it's looked up a couple of the specific key points. And then I've given it that context at the end and said, okay, now rewrite the summary, but with the citations. So that's how I'm getting, like, the number 1 and the number 2 in here. This is kind of choosing the best place to put them. Cool. So that is, that's quite a, involved process. It took a couple of days. I would say that the amount of prompt engineering you need, you're probably not going to know ahead of time. It's a very, it's an R&D type task where you could be working on it for a month and find out that you basically, can't crack the solution. Or you might be doing it for an hour and then you happen upon a good prompt and you're like, okay, great, this is working, which is nice. So I'd say it's a creative task, just like any other creative task. You can't really schedule it that well. What I would try and do is time box it and say, we're going to try and spend 2 days on this and see how far we can get. And then based on how far we can get, we can revise our plan and kind of say, okay, maybe we need to try another solution. Or maybe this isn't good to do with AI right now. And we can put that in the box for later when the next model comes out. Cool. So what do you do when you get into production? So say everything goes really well. What is a prompt engineer doing then? Like, they're not just kind of creating new prompts for new tasks. They're also optimizing existing ones. And that tends to fall into 3 buckets. And I would say the first of those buckets is A/B testing. Quite often, now you have an evaluation metric, now you have kind of a general system, and you know what the output should be. You can try a new prompt, and you can see what the results are against your evaluation. You can try a new model and see how well that model does, from a different vendor perhaps. You can actually A/B test to decrease costs as well. So, you get it working with GPT-4, and then you try and get it working with GPT-4 Mini, right, which is, 100th of the cost or something. I'm seeing a lot of people, particularly from the machine learning engineer kind of background doing optimization work with some of these frameworks that are coming out. Like Microsoft has one called Ammo. The most popular one is DSPy. And the nice thing about this is that if you give it an evaluation metric that it can run, and if you give it the initial instructions, then it can rewrite the prompt for you. So it will choose what few-shot examples to put in the prompt, the ones that pass the evaluation the most, and then it can also rewrite the actual instructions in a way that an LLM will give better results from. And that is, it's unusual that that works, but I guess in a way, like prompt engineers are not immune to being automated out of a job either. Like that's what we're doing for other people, I guess. I don't know, DSPy, like because AI models are good at most, like a lot of human tasks, it makes sense that it would also be good at doing prompt engineering. I would say that this tends to work better for specific types of classification tasks where the evaluation is quick and cheap to run, and less good for larger tasks like actually summarization, where it's very expensive to run it 100 or 1,000 times. And in that case, I think humans have better intuition for getting to a good prompt with less tests. And then there's also fine-tuning, and this is the last step, not a first step. A lot of people try and skip straight to fine-tuning because I think investors like it when you say you have your own model. But honestly, I would say that if you go through all of these other steps first, then you'll have the database ready for fine-tuning because you have your evaluation metric. You can run the prompt a bunch of times and then generate, say, 2,000 responses that pass your evaluation metric, right? So like you can build that data set very quickly once you've gone through these necessary steps. And with fine-tuning, you're going to find that you need hundreds, maybe thousands of examples before the model gets really noticeably better. Fine-tuning is also not always available. Like GPT-4 was only generally available for fine-tuning a year after it came out. So, like tends to be something that people are using more for smaller tasks that work on the smaller open source models. So dive in a little bit deeper into these, and I'm not sure how much time we have left, but we can kind of about 5 minutes. Okay, so we'll just cover a few of these relatively quickly, but you'll also have these slides afterwards. There's an example of an A/B test. It's literally just a simple function that calls the one I talked about earlier, where you call OpenAI. The key is that it's you want to try and run it asynchronously quite often. Because otherwise when you're running 10, 20, 30 times, it's going to be really slow if you're doing it one after another. You want to be able to do multiple batches at the same time. In this, with these types of prompts, I tend to run it between 10 and 30 times each, because that just removes some of the randomness out of the responses. And if you can average the evaluation scores, then you're just decreasing the chance that you just got unlucky with that training run, right? You might find that you're throwing away a good prompt by accident because the first few times you ran it, it was bad, right? I tend to look at prompt engineering papers for good ideas. If you don't want to read prompt engineering papers or you don't have enough time, then you can also use ChatGPT and Claude to read those papers for you and tell you what is the prompt they used here, and then you could just try that for yourself, right? So again, we're using AI at every step of the way, which is quite fun. DSPy is like really interesting. I'd say it's still relatively new and like changing a lot. It's like more in alpha than beta, but I wouldn't use that in production. But what I would do is take your prompt out, run it, recreate it in DSPy, and then run some testing, kind of optimize it, and see what results you can get. At the very least, it will give you some ideas of different prompts you could try, and good ideas of what few-shot examples to include. Typically, I wouldn't try it without having like at least 50 data points, and I try it more on classification tasks, like where there is a right answer. It tends to work a lot better than more creative tasks, like write a blog post or write a social media post. Be careful of costs because, and you can calculate this ahead of time, but if you use something like MePro, which is testing both the instructions and the few-shot examples, and you're using GPT-4 instead of GPT-4 Mini, you could easily spend a few hundred or maybe even $1,000 on that training run. So that might be more or less consequential depending on the resources you're using for that project. And then fine-tuning, thankfully, is like very easy to run, although very complicated to understand what's happening. So if you don't have a machine learning background, or you don't have anyone on the team that understands this stuff or can spend some time digging in, then I would just stick with the defaults, follow a tutorial, see if it works. If it doesn't work, then decide whether you want to go deeper with it. And I found that on average, it tends to work when I've got more like 2,000 examples of inputs and outputs. So I'll do all the prompt engineering stuff first, and then I'll try a fine-tuning run. And if that doesn't work, then I'll kind of reconsider my strategies. Typically, the model vendors themselves control this, right? So you can't just train GPT-4 without permission. Right? You don't have the model weights to update. So actually, I tried to do fine-tuning on this data set, and OpenAI told me no because I mentioned the word Donald Trump too many times in my data, right? So, I mean, you do run into some kind of limitations there. If it's not your weights, it's not your model, right? So what a lot of people do, the pattern I'm seeing is distillation, where you use GPT-4 to generate lots of really great examples that are working and passing your evaluation. And then you go and use like an open source model that's cheaper to run, that can be self-hosted on your Azure setup or AWS. And then you just train that with those examples. And that does work pretty well. Quite often you can get a much smaller model up to the same standard as GPT-4 with a few thousand examples. So it could cost as low as a few $100, and then you have like a smaller, cheaper model that costs like less than a penny per 100,000 tokens. So that is quite a common use case. You don't have to run these models locally on your computer. If you have privacy or sensitive data issues, then obviously you want to work with your organizations to self-host or use Bedrock or one of the other kind of trusted platform providers. But I often use a tool called Replicate just because it's quite simple. They kind of host these models for you and have good tutorials for how to do fine-tuning. And then last thing is just like other things that help. Adding more eval metrics. Just having one eval metric is good, but having multiple ones that cover different things that people complain about, that's better. Working with domain experts to get more examples. So don't just stop when you've got the prompt working. You can always make it better. Adding more test cases. Whenever something fails in production, you want to add that as a test case. So you can check if it's regressing. And you can check when you update to the new model whether it's still passing all of your test cases. And those test cases are just input and output pairs. You want to train an LLM judge, we talked about. If you can automate the expert feedback and it agrees enough, like 80% accuracy versus the human expert, then you can run A/B tests much, much faster. And then you can create like a self-improving loop there, especially if the feedback is coming in directly from production. Like people can click on an answer and say thumbs up. That tends to be quite helpful. And then really after that, you're talking about things outside of AI, like connecting it to other systems, like databases where it can do searches, and kind of pulling in the right context for the AI to do a better job, and kind of splitting that up into multiple tasks that maybe all run in parallel as well. Cool. So I have a few different things here that we're not going to go through, but these are just individual papers that might be worth looking at. The main one is that prompting tends to beat fine-tuning under 2,000 data points, which is really helpful, and then kind of like a roadmap for this is what OpenAI recommends in terms of how you should approach this. Cool. Thanks for listening.